important. Why is it important? Because for fluid mechanics problem is normally given S, not given gamma, not given rho, so given normally S. And from S, you can calculate the gamma for the fluid. What is equal S is equal gamma for fluid by gamma of water, which is mean normalized the gamma of the fluid by gamma of water, which is equivalent also rho of fluid by rho of water. The same meaning. What I mean for this, I'll give you a simple example for that. If I give you Cg for the oil, for example, is 0.7. So it means gamma water is equal 9810. So what is means this one? The gamma fluid, gamma water is equal 0.7, which is Sg. What's referred here for fluid? This is oil actually. So it means gamma oil is equal 0.9, gamma water, so is equal 0.9 multiply 9810. Okay, but if I give you raw water instead of gamma water, so I use the same. Raw water is equal 1000. So raw water, raw oil is equal 0.9. Why 0.9? This is 0.9 because I use here 0.9. No one tell me. This is 0.9, 0.9, 0.9. This is 0.9 multiply 1000. So I get raw oil. Okay. For example, Sg is equal 101. So 101 multiply gamma water, or 101 multiply raw water. Okay. Bulk modulus of elasticity. This also property is also property, but refer to what? This property, it is referred to change of pressure to the change in volume. So to be easy, for one meaning easy, it measures elasticity of a fluid. Elasticity of a fluid. What's the meaning of that? Let's see. If you have two material, two fluid. This fluid, you know fluid, liquid or gas. You have two fluid like this. Okay. Okay. I apply by pressure. Okay. You need to fix it one. You have two parameters, pressure and volume. Should be keep one constant to measure the other one, to can measure the meaning of bulk modulus. So I keep the change of volume the same. So it means I apply by pressure, but to keep here the volume, make a change of the volume here, delta V. The same change of the volume here, delta V. So here the same change of volume happened. But to make the same change of volume for the, this is we can set A, this is can set B. This required B1 to make this a change, but this required B2 to make this a change. And B2 is less than B1. So what's meaning of this? What we conclude that? This is conclude, give me as conclusion. What is this conclusion? One of this material is easier to compress rather than the other one, correct?
Yes, sir.
Sure. Which one is easier to compress?
B2. B.
B. Why? Because this is actually need little pressure to make the same change of volume, correct?
Yes.
Actually, this is the concept of bulk modulus of elasticity. They give you values. This value is property for the material. When this value is little than the other value, so it means this related for fluid is easier to compress or more elastic rather than the other. Clear? What is the equation used here? The equation for bulk modulus of elasticity E is equal to the change of pressure to the change of volume, but this is not a change of volume. This is delta V over V. Yes, we put the denominator here as a percentage. It means the change of volume to the total volume. So write it here as a percentage, which is mean I needed this part as a dimensionless for denominator to keep this unit for the bulk modulus is the same unit for the pressure. That's it. So this unit is Newton per meter square, which is Pascal, the same unit of pressure. So it gives you the same indication, delta V or delta V or V. Yes, delta V is the value. Delta V over V, and no problem, is a percentage, which is delta V over V here, 10%. Delta V over V here is 10%. Clear this? Let's read this question, please. Bulk modulus of elasticity of ethyl alcohol is 1.06, 10 to the power 9 Pascal. For water, it is 2.15, 10 to the power 9 Pascal. Which of these liquids is easier to compress?
Ethyl alcohol, because the pressure is required is less.
Again?
Ethyl alcohol, because the pressure is less.
Yes, exactly. Ethyl alcohol, because this is required little pressure to make the same change of the volume. Exactly. Viscosity. Viscosity, one of the important property for fluid mechanics. Let's see what is the definition to can understand the equation created here. Viscosity mu, it is a fluid property. It's okay, representing the resistance of the fluid to deformation by shear stress. So the flow is moving like this. Due to the flow moving, what happened? The layer have a shift between layers. Due to what? Due to the lower layer here is contact with the stationary plate, for example. So for sure, this is more resistance with the fixed one. So it's almost zero. The layer contact with this is not moving. And when you go up, the layer is this one is make a friction with the below one. So it is moving, but it's still low, and go up and up and up. When you go up, the layer, it will be more free, so it will be more accelerated. So the velocity here is higher, which is free moving. This is what's describing here for this curve. The velocity here is 0, and the velocity here is maximum for the free one. So we have something is said velocity gradient. You see this distribution is said velocity gradient. So it said what? Velocity gradient. Okay. So this is said what? This is said velocity gradient. This distribution is said velocity gradient. Not all the time is linear like this, but I give you the simple way, because if it is other side or other way, it should be something like this, parabola like this. Okay, but for parabola like this, it should be given the equation for this one. And instead of this distribution is delta u by delta y, it will be partial u partial y, or du by dy, something like this. Okay. It's like the direct differentiation between the velocity and distance or elevation or transitions like this. Okay. Full linear, we can make it as a change directly, delta u by delta y. What is said this one? Please, the name for this term is very important. You have to name for this, and many engineering drop for this question, theoretical questions. This name for delta u by delta y, first name is velocity gradient. Please, one word, not enough. Velocity gradient. And second name, rate of shear strain or rate of strain, whatever, rate of strain or rate of shear strain. Okay, whatever is this name. Clear? So this one is direction or position here, y, and this is a velocity distribution. Clear? So concluded from that, the equation, this is velocity gradient. Sorry, this is shear stress created from the friction between layers. This shear stress is equal to mu, which is viscosity, multiply delta u by delta y, which is referred to velocity gradient. Okay? The unit of the mu is Newton second per meter square, and the other unit is one of the famous units is poise. Okay? Other, what is the name for this? Dynamic viscosity, absolute viscosity, viscosity as it is, all the same, refer to mu. We have another name is kinematic viscosity. Kinematic viscosity. This kinematic viscosity, nu. What is nu? This is actually normalized the viscosity by density. Normalized the viscosity by density. So we get it another property said nu, kinematic viscosity. The unit for this one is meter square per second, and sometimes we have another unit is same like this. A regular unit like this poise is here is stocks. Is what? Stocks. Okay. So nu is equal what? Mu by rho. Read this carefully. Read first, please, and we'll solve it together. Please, someone ask for the passcode from 10 minutes or 15 minutes. Could you please anyone to share the passcode for the password or for the link? I don't know if it is already joined or not yet, but please send the passcode on the WhatsApp group. Okay, let's start the problem. Here's a plate, 20 centimeter, 20 centimeter, 1 centimeter, this plate, and it's filled with a liquid of viscosity 1 boys. This liquid here, and the liquid here is 1 boys. What is this 1 boys? This mu. What is the conversion between boys and the normal standard units? 1 boys is equal 0.1 Newton second per meter square. To be remembered. Our plate is dragged to the right with a force 5 Newton. So the force here is 5 Newton. Keeping the lower plate stationary, what will be the velocity meter per second of flow at a point 0.5 above the upper plate, upper surface of the lower plate. So upper surface of the lower plate 0.5 from this. So I needed here this point request 0.5 centimeter. If linear velocity is applied, so this one here is supposed to be linear. This is linear profile. Okay. Let's start. To start for this one, we need mu at 0.5. Let's write the equation. Tau is equal mu delta U by delta Y. Tau, we don't have tau direct, so we have another way to get tau. Yes, this shear stress. Shear stress is equal force by area. So this force by area equal mu. What is delta U by delta Y? This U2 minus U1 by Y2 minus Y1. Okay, Y2 actually, this is required. U2 is required. Y2 is equal to 0.5 centimeter. U1 and Y1. I search for point. We know this condition for this point. This is stationary line, correct? So sure this point is what? This is stationary point. So U1 is 0 at Y1 is 0. This is like initial condition. So force is 5 Newton, so 5 Newton. By area, which is pi over 4, sorry, not this circular, this plate. So plate shear is contact plate. So which area? 1 multiply 20 or 20 multiply 20. Which area is contact for the flow? Contact. The area contact with the flow is 20 multiply 20. This is the contact actually. Not this not contact with the flow. Here. So here it will be 2020. It means 0.2. 0.2. Equal mu, which is 0.1, 1 boys. U2 required, minus 0. Y2 0.5 centimeter, change to meter, it means 5, correct? Yes, minus 0. From this we can get U2, which is unknown value. It will be what? 6.25. Any question? Any question?
No, sir. Clear.
Here, this profile gives a relation between shear stress now and velocity gradient delta U by delta Y. You see one profile, here is linear. Linear, it means this is one follows the viscosity relation. This is here the change of y-axis. This is the change of x-axis. So this is given the slope, which is mu, referred to mu. What is the type for this one? Is Newtonian flow. So viscosity is only follow Newtonian flow. What? Newtonian fluid. So for any type of other fluid like non-Newtonian fluid or other thing, we can't apply for the equation of the viscosity. Only applied for Newtonian fluid. Newtonian law of viscosity is relationship between
B.
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 Relationship with stress and strain. Yeah.
Shear stress and relative shear strain. Exactly. C is wrong. And this is the main engineering is in different patches. Select C, which is wrong. Please careful. Density of water is 1000. At which condition?
At 4C, B.
All of the above.
None of the above.
Yes, a specific weight of water in SI.
Rho phi G.
Specific weight is gamma, is rho G. So
10,000.
0.8 multiplied to rho C.
Yes. See.
Which of the following is dimensionless?
Specific viscosity, D or E?
D.
Specific gravity. Yeah.
Let's see another property. Also, this property is very important, mainly for one of the famous applications for mechanical pumps application. What's meaning first for the property and see what's the problem. First, the property is said vapor pressure. What's vapor pressure? It's the pressure at which a liquid will vaporize or boil at a given temperature. You can use this point to be understand for all. If I ask you one question and I tell you what is the boil temperature for the water?
100 degrees. 100 degrees centigrade.
What?
100 degrees centigrade. 100 degrees centigrade.
100 degrees centigrade.
Boiling temperature of water.
Is this what you said?
100 degrees centigrade.
Only you said 100 degree also? Nothing more information? Only 100?
At normal place, sir.
Yes, this
1
is
bar.
This is it's not easy, this name, this addition.